Welcome to this Subglobal Assessment Network webinar. Thank you very much for joining us for this session. This is the first in a short series of webinars that the SGA Network Secretariat will be hosting. The next will be during the first week of May. I shall circulate registration details for the second webinar during the course of the next week. For the second webinar, we will partner with Carl Obst and will focus on natural capital accounting. For those of our audience whom are unfamiliar with the Subglobal Assessment or SGA network, we are a network that seeks to create a common platform for practitioners involved in ecosystem assessment with the intention to promote and facilitate improved capacity to undertake and use ecosystem assessments. The Subglobal Assessment Network was developed in order to provide a support network for the Subglobal Assessment Network assessments carried out under Millennium Ecosystem Assessment process, and has continued to develop and grow from that point onwards. If you are not already signed up as a member of the SGA network and would like to be, please contact the Network Secretariat by emailing assessment@unep-wcmc.org. You can also visit the SGA network website for further information. This is www.ecosystemassessments.net. This is shown at the bottom of your screens now. You can also follow us on Twitter by searching the Twitter username @SGA_network or on Facebook by searching Subglobal Assessment Network. Today's webinar will focus on TESSA, the Toolkit for Ecosystem Service Site-Based Assessment. For this webinar, we have partnered with Jennifer Birch from BirdLife International, one of the partners of the consortium responsible for developing TESSA. Jenny is the Ecosystem Services Officer working as part of the Science, Policy and Information Management team at the BirdLife International Global Secretariat based here in Cambridge. Jenny leads on the development of BirdLife scientific work on ecosystem services, specifically in managing and supporting projects working with BirdLife partners in South America, Asia, Africa and the Pacific, and working closely with colleagues through a number of Cambridge Conservation Initiative collaborative projects. Jenny is currently the coordinator for the TESSA Steering Committee. As such, Jenny is coordinating further development of the tool in addition to supporting partners and others to use it. Jenny is also currently piloting TESSA with several BirdLife partners globally. During this webinar, we do not intend to disrupt the progress with hand raises and will not be responding to them. If you would like to pose a question, please submit these throughout the course of the webinar, and we will do our best to answer these in a Q&A session at the end of Jenny's presentation. The Q&A session will run for no more than 30 minutes, and questions will be clustered into similar themes and topics if they emerge. Following the closing of the webinar session, I would like to invite you to join us on the SGA Network Forum to continue discussions around TESSA. So please visit the website that is on your screens now in order to post questions about today's webinar. I will hand over to Jenny to talk you through the TESSA Toolkit now. I hope you find the session both interesting and useful. Thank you.
Okay, so firstly, thank you to the SGA Network Secretariat for inviting me to give this webinar today. So I'm going to start by giving you a quick background to the toolkit TESSA, and then an overview of the TESSA approach, including some details on the methods incorporated into the toolkit. I'll then finish by showing you briefly some of the impact we've had to date through the pilot studies and other work that we're aware of on globally, and then let you know what's coming up in the future in terms of continued development. So as you'll all be aware, ecosystem services have really been in increasing profile at the international level over the past couple of decades. In 2005, there was the Millennium Ecosystem Assessment Report. In 2010, the TEB, the Economics of Ecosystems and Biodiversity, and more recently, the formation of a partnership of countries looking at wealth accounting and including the value of ecosystem services beyond the countries looking at GDP measures. There are a range of tools available for assessment, and I'm sure a number of you are very aware of those. TESSA is one of these tools and is applicable in certain cases where other tools may be useful elsewhere. And it's important to consider that these tools often operate at different scales. So there are some tools that are more useful at the local level and others that perhaps can be applied at national and global scales. So the thinking behind TESSA was started here in Cambridge in 2009 when a workshop was held as part of a horizon scanning exercise, and a number of academics from the university and conservation practitioners realized that there was not really a tool out there that was addressing site level issues that could be applied by non-experts and collecting locally relevant data useful for local decision making. So the objective of developing TESSA was to develop and deploy a rapid assessment tool to understand how conservation of sites that are important for biodiversity can also help to conserve and provide different ecosystem services relative to if that site was perhaps converted to another state. So some of the key aspects that we were thinking about in terms of the development of this tool were to ensure that it could be applied by non-experts. Many of these people are working on the ground in local situations and need to have access to tools. That it could be rapid, so it wouldn't be too intensive, requiring a lot of resources. Also available for people with limited capacity in terms of staff, time and money. That it would be participatory, so involving a lot of local level stakeholders throughout the process, including in the decision making and in the reporting of results. But also that it would be scientifically robust and therefore a reliable method for people to use with confidence. This has been a collaborative process between the partners that you can see highlighted at the top on the slide. It started off with 3 workshops based in Cambridge in the UK, where we engaged over 50 experts in the idea behind developing this toolkit. We then had 30 external reviewers look at a first draft in 2011, and during the last 3 years we've piloted the toolkit at more than 10 sites globally, with other partners also implementing it without our direct involvement. We continue to have regular steering committee meetings, which I coordinate, and we are providing technical support to a number of people, including BirdLife partners and others from the network, to help them to apply the toolkit and to get their feedback on the usefulness of it and how we might improve it. So the toolkit itself at the moment is a downloadable document. I will provide the link later on in the slides. And as I said, it guides non-specialists through a selection of accessible and low-cost methods so that people can identify important ecosystem services at a site, evaluate the benefits that people get now, and compare those to the site under an alternative land use. So you're probably interested to know how this is different from some of the other tools that are available. Firstly, it focuses very much on primary data collection so that the locally relevant data can be gathered and applied. However, it also provides methods if people are unable to collect data in the field that allow people to use existing data and benefits transfer where appropriate. It requires fairly low specialist technical knowledge, so there are no GIS programs in there. There is a limited amount of computer interaction, but due to the data analysis required, people would need some basic Excel and mathematical understanding. It's also relevant at the site scale, so this is not a tool for addressing issues across large catchments or regions. It's much more focused on areas such as protected areas, important bird and biodiversity areas, or for instance community conserved areas. So the scope of the tool covers at the moment 5 groups of services: global climate regulation, harvested wild goods, which many refer to as non-timber forest products, but this group also includes timber as a harvested wild good. Water-related services, this includes flood protection, water quality, and also the regulation of water provision. Nature-based recreation is covered, and also cultivated goods. So I'll just spend the next few minutes going through the steps in the toolkit. There is a flow chart at the beginning of the document, and on the side of the slide here we'll work through each of the steps just to give you an idea of what's involved in one of these assessments. So the first objective is to do some preliminary work, and I've listed a few of the key bits of information that you might collect at this stage. So that would include understanding and defining your area, defining your objectives and also your audience. And this is very important because the information that you collect will be influenced by what your objective is and who you want to communicate this to. Understanding how your data will fit into policy processes is also an important consideration right at the outset of your assessment. So is it possible to identify how your results could be integrated into policy processes or communicated at important meetings or events, perhaps in government or at local level council meetings? At this stage, it's also important to understand the local context. Now, many of the people implementing TESSA will be working at the site and may have been working there for many years. So probably have a fairly good understanding of things like politics, the social structure, access rights to resources, perhaps also the ecology of the ecosystem. If people aren't familiar with this, then TESSA suggests that time is spent familiarising with these issues, as they will influence what you then go on to decide to measure and explore. So talking to people informally is a key part of this assessment, getting that qualitative information and local knowledge. So the second step is then to conduct what we call a rapid appraisal, and this is essentially a scoping assessment which has a number of purposes. So it is meant to help identify and engage relevant stakeholders and bring them into the process, to enable you to verify the habitats at your site, to understand the areas of these habitats, and also the drivers of change. So what is influencing the habitat areas? What are the pressures on biodiversity and on the ecosystems of the site? The second step is within this process is to then identify the most important services and to understand who is benefiting from those currently. So that involves a lot of discussion with stakeholders, perhaps in a workshop setting. And also this rapid appraisal allows you to explore possible alternative situations, either land use situations or different ways of managing the site, and to consider what this might mean for both the biodiversity of the site, but then also the services that it provides and what that means for people. So this is just an example graph of one of the outputs of a rapid appraisal, which we provide in the toolkit as a two-part sort of questionnaire that people work through. And it essentially just shows very simply what this group felt might be the changes from an alternative land use in terms of a number of ecosystem services, with some increasing a small amount or a lot and some decreasing a small amount or a lot. So once the rapid appraisal has been completed, the next step is then what we call identifying the plausible alternative state, and I'll spend a couple of minutes explaining exactly what this means. So the idea of comparing two different states is taken from economic principles, and it's not just to look at the gross values or the total value of a site, but to look at the difference in terms of ecosystem service values and provision between two different states. This can provide important information on the likely impacts of decisions or different policies in place, so it can therefore inform decisions made about land use. It can also help to identify trade-offs. So these might be trade-offs between biodiversity and ecosystem services, between different ecosystem services being provided under different land use situations, and also between different beneficiaries, depending on which ecosystem services people value or depend on more than others. So I'll just give a couple of examples of what we mean by the idea of having two alternative states. So this little picture here shows that a policy action might be identified, and under scenario A you would not implement that policy action, and on scenario B you would implement that action. So for example, without implementing an action at this site, business as usual would probably be oil palm development, whereas if you applied a policy perhaps to not allow the development to go ahead, then the forest might remain in its natural state. In the second example, this is a coastal example where perhaps there is unsustainable fishing occurring, and a policy action identified and implemented might be to put in place marine protected areas. And what TESSA would do would be to look at the various ecosystem services delivered under both of these states and compare the two. So just to give you a real example from one of the studies that we did in Nepal, the first process here was to get together with some of the local people, including the District Forest Office, to discuss what the alternative state of their community forest might be. And in this case, they drew on a topographical map to show how the forest was in the past, that is before community forestry was implemented. And this enabled us to then come up with two land cover maps. The percentages of different land covers are provided here, where essentially the unmanaged state forest has a much greater proportion of degraded forest and cropland than the community forest, which is predominantly mixed broadleaf forest. So once you've decided what your actual alternative state would be, it's then necessary to locate a physical place where measurements can be taken that are representative of this alternative state. So this diagram here shows an example for a forested mountain where under the alternative state the forest on the lower slopes is expected to be cleared for agriculture, leaving the forest untouched at the peak. And there are two options for actually looking at what the services might be for the area that would be cleared. One option would be to look at the lower slopes where they have already been cleared on that mountain and to take data from the crop cultivation from that area, or alternatively to look for another similar mountain that has the same soil, climatic situation and topography, and to take data from there and extrapolate it across to the area that you anticipate would become cultivated under your alternative state. So this is an example from that site in Nepal where the black boundary shows the boundary of Phulchoki forest, which is a community forest. That's our current state, which is also an important bird and biodiversity area. To look at the alternative, which was a combination of degraded forest and agriculture, we undertook surveys outside of the IBA in a location that had already been converted to agriculture, but also at a small area within the IBA, but where there was a lot more degraded forest than in other areas. So that's where the measurements were taken and then extrapolated back up to the land cover areas that were shown on the pie charts a couple of slides ago. So the reason for doing this is based around the concept that was published in Science in 2002 by Bamford and colleagues. And he gathered information from 5 studies globally, which allowed them to assess the net present value, the economic value of sites under conservation versus those sites under some other conversion. For instance, conventional logging, shrimp farming, or destructive fishing. And what was interesting in the results was that in each case, the economic value from conserving these sites was greater than the economic value from conversion once these ecosystem services were incorporated into the assessment. So just a second example here, just to illustrate a different ecosystem. This is a wetland in the southeast of Nepal, and it is currently a protected Ramsar site. So it has wetland grasses, some forest areas, and is grazed by wild herbivores. The stakeholder participatory meeting decided that the alternative state would be unrestricted domestic cattle grazing, which is currently the greatest pressure on this reserve. And that would lead to a loss of wetland grasses and a loss of forest habitats that are important for a number of different birds and other species. So in terms of what we actually did, again, similar to the forest example, we took measurements at our site of interest of a number of ecosystem services, and also then chose a site in the northern buffer zone as our alternative location to take measurements where there was a great deal of cattle grazing. So moving on to step 4, so this is where I'll give you some details about the actual methods behind TESSA. So there's over 50 methods in the toolkit across all these different services, and the preliminary work that you will have done in the rapid appraisal will enable you to make a decision on which methods might be appropriate, and that will also be influenced by which methods people have identified as being important, what resources you have, the time and the staff available, and what will be interesting to present to your audience that you have considered right at the beginning of the assessment. So in this example, the black boxes show the methods that were used, which range from secondary data, so that's just using existing lookup tables, to participatory approaches, semi-structured interviews at the household level, and also looking at water services using a modelling tool, which I will mention shortly. So the methods then enable you to collect data both for your current and for your alternative state. So I'm going to give a couple of examples for each of the services in the toolkit. So firstly, looking at carbon stock, which comes under the Global Climate Regulation section. This service, as with all the others, will start with a flow diagram directing you through a series of questions that then allow you to refer to the most appropriate method depending on your site. Each of these flow diagrams is specific for the service and asks key questions, hopefully allowing you to use the most appropriate method. So for carbon, there's basically 2 different approaches. One is to use data that's already available, such as the IPCC information that has above ground biomass values for different habitats in different biomes. Of course, the error on this can be quite large, and you may decide that you would rather use more local existing data that might be available, or even to collect your own. So there are methods in the toolkit for not just tree-dominated habitats, but also for looking at carbon values in grasslands and wetlands. And this involves essentially sampling your area, doing a number of survey plots, and using the information to convert values to a biomass and then to a carbon stock per unit area. In a tree habitat, the standard way to do this is to measure the diameter at breast height of the trees, as this guy is doing here, and then to use what we call allometric equations to convert your diameter at breast height to a biomass for each tree, then to a carbon amount, and then those can be averaged over perhaps per hectare. A price can also be added to carbon. There are some guidelines in the toolkit on how to do this, but there is no fixed carbon price, so that's quite a tricky area, and it's best to use a variety of prices to look at the effect that that has on your results. So just flicking through then to some of the water services. So similarly, these will each start with a flow diagram, which should help you to get directed to the most appropriate methods. With the water services, it's often necessary to have a lot of background information before you actually go through the method. So in the toolkit, there's quite a lot of guidance on what sort of information you might need, and on how to go about getting that information to help inform you which services you can assess based on the information you have available. Water quality is another of the water-related services that is assessed, and the toolkit splits sites into essentially wetlands or sloping terrains in order to give you some methods to do this. In wetlands, it's quite tricky to do on-the-ground rapid assessment of water quality. We do have some methods in the toolkit, but not all wetlands will be applicable because it needs to be a fairly simple system in order to apply the methods that we have in TESSA. Water regulation is the third of the water services, and one of the methods to look at this is actually using a modelling tool, which can also be used to look at water quality. And although we've tried to avoid some of these more technical methods in the toolkit, we decided that this tool, which is freely available, it's hosted online, and they provide free support and training, that this would be a good method to rapidly look at water provision and quality for a site scale assessment. So I won't go into details on WaterWorld, but the link is here for you to find out more information. They do provide training courses remotely and also here in the UK, and I think also in some South American countries. So if you're interested to learn more about that, then please go to their website. So moving on to the harvested wild goods, again the flowchart will lead you down through to a couple of methods, and there's fewer methods in this section than in, for instance, the global carbon and the water sections, because this predominantly focuses on people getting information from the local users of these resources, so through focus groups, participatory workshops, and also household surveys. So this is an example here of a very simple survey that was done at the household level in Koshi Tapu in the southeast of Nepal, where we asked questions on 5 different harvested wild goods, both for the harvesting within the reserve and also where we were doing the alternative state measurements. So some templates of these questionnaires are provided in the toolkit, but it is important to realise that these are just templates and they will have to be adapted according to the local context. Cultivated goods is a very similar flowchart because it uses very similar methods through collecting information from key informants or through a household survey, perhaps with people you know are farming, for example. I will just show one example from the UK here, from an area very close to Cambridge called Wicken Fen. This is a site that has old peatlands, so some undrained area with very deep peat reserves. And the National Trust is an organisation that wants to restore areas that have turned over to arable farming back into fen wetland areas in order to build up the peat again and provide habitat for a large number of species. So at this site they were looking at the value of the land in the surrounding area in the yellow here for arable crops versus the value of the land of the restored fen. And to get information on the crops, they actually used existing data. So there was a land use survey back from 2008 which showed the proportion of land under different crop types. There was a farm business survey database available for everywhere in the UK, which for this region provided net farm income values per hectare. And they were able to use this information to calculate the total annual net income of the land were it to be used for farming instead of restored to wetland. So in this case they didn't actually collect any primary data because there was a lot of good data already available. So the final service, just to give you an idea of, is nature-based recreation, and this is also focused on questionnaires and asking visitors to a site on their reasons for visiting and also getting some travel cost information from them. So in this case, in order to evaluate the value of the site under an alternative state for its nature-based recreation, we ask for the stated preference of visitors to determine whether they would return if the site was under some alternative land use. And by looking at the difference in number of visitors and therefore average spend between those who would remain coming to the site and those who wouldn't, we can assess the net value of the site for its nature-based recreation. So once the methods have been chosen and then the data has been collected on as many of those services as are relevant for the site, there's then the process of analysing and communicating that information. And I won't go into detail on that here, but I've just highlighted some essential things to think about. So as mentioned earlier, be clear on your objective at the start of your study. Identify and know your target audience so that the way in which you analyse and present your data will be of interest and of relevance. Consider other measures of looking at data that don't just apply the economics. Often there are many factors that may influence decisions, such as number of people affected or unaffected, number of people in employment, and other measures that don't just rely on putting an economic value. And also including consideration of those services which perhaps haven't been evaluated. TESSA only covers 5 or so services. There will be many others that are important to people either locally, nationally or globally. And as you do the assessment, it's quite likely that you'll understand a bit more about the importance of these. So it's important to consider that in the report rather than just focusing on producing graphs based tightly around the quantitative data that you've gathered. So as I've said here, don't overlook the importance of including that qualitative information that you've got. So here are just a few examples so you get an idea of what sort of results can be generated. So this is just a very simple graph showing above ground carbon stock in tonnes per hectare for a site currently and under an alternative state. For flood protection value, in this case the comparison was between, this was at Wicken Fen, so the farmland value of flood protection, which was valued at 0, versus the wetland because of its storage capacity. And this was based, as I said, on data provided that was already available. Here is an output from the Water World model, which produces maps that can be produced in a variety of forms. Here it's focused on the important bird area Phulchoki, just outside of Kathmandu in Nepal, and it shows that agricultural pollution increases the human footprint on water quality as much as 70%. So the areas in red, which are effectively inside the site, were they to be converted to agriculture, would have a huge impact on the quality of the water flowing from that site, but only at fairly local level. So the bluer the rivers become, the less the impact is, because those rivers are being diluted by water from elsewhere, so the effect of the pollution is much reduced. And here's another example of a graphic looking at the difference between Phulchoki under community forestry and under an unmanaged state where there will be a lot of degradation, and visitors saying that they would, many of them would not visit, and therefore the income per year from visitors would be greatly reduced if the site was converted and was no longer forest. So I just wanted to also highlight that the toolkit doesn't just recommend the production of graphs on aggregate values, but also the importance of considering how those benefits are distributed. So in this example, which is taken from a paper published in 2009, box 1 shows the service, that's S, and the beneficiaries, B, both located in the same site. So an example of this would be, for instance, harvested wild medicinal herbs, where people are living in the forest and getting that benefit directly from where they live. In the second box, the service is being provided by a site to beneficiaries living just outside. So a good example of this would be something like pollination, where the habitat for the pollinators is within the forest and they're benefiting people who have crops just outside. In box 3, this is a downstream benefit, so most relevant for water services. But for instance, the service could be the ability of the forest to hold on to the soil so that soil erosion is reduced and impacts less on the beneficiaries living downstream. And in the fourth box, this is a directional benefit also to local beneficiaries in one direction. So the obvious example here is a coastal protection service, perhaps from some mangroves aligning the shore, preventing storm surges from affecting beneficiaries living and growing crops behind. So the importance of highlighting this is that it's important to understand how services are benefiting people, both at the local level, but also nationally and in some cases globally. So in all of our results, we haven't only provided information like this, which shows the net difference in terms of economic value of services between two states, but also information on what that means for beneficiaries. So this second table here shows in a quantitative way where negative values mean that that beneficiary group will lose out. Positive symbols mean that they will gain from a change in state, and the equal sign there means that there would be no significant change in the service to that beneficiary group. So this hopefully enables people to see the overall effect of a decision on the provision of services to different people. So just a second example here is from Montserrat in the Caribbean. This is an island where they're trying to limit the impact of feral livestock on the habitat of the Central Hills Reserve, which is just north of the exclusion zone where the volcano erupted. And what we showed at this site is that currently, as a protected reserve and with the livestock management program in place, services are being delivered better than they would be delivered if the livestock was no longer being controlled. And just a final study here, Wicken Fen, that's just up the road here in East Anglia in the UK. Again, looking at the difference in terms of the economic benefits of farmland versus restored fenland, but also looking at what that means for different groups of people. And in this example, they were looking at the benefits from restoration, showing that locally, nationally and globally, overall, people were benefiting more broadly from the restored site. So just to provide perhaps some key information that people are often interested in terms of what's involved in the toolkit. So we would imagine that the direct users of this TESSA tool would be practitioners working in the field, such as conservation professionals, project managers, technical field officers, and also students. The time required for collecting data, which is based on 27 sites where we have this information, is about 56 person days. So that's about 11 weeks or near 3 months for one person. So if you had a team, then this would obviously take less time. And the average field cost is around $6,500, and that is based on data from 19 sites where we have this available. So just to show you some of the studies that partners of TESSA have been involved with globally, I've just highlighted most of the ones that I'm aware of here. So TESSA has been applied already in over 20 countries across 5 continents, most recently at 11 sites in Africa through a training program that we offered last year. And there's quite a lot of text on this slide, so perhaps you don't need to read it now but could have a look at a later date. This is an example of some of the impact that TESSA has had at different sites. So perhaps just picking up on Rara National Park in Nepal, where the information is being used to try and reinstate community forests in the buffer zone to enable more sustainable use and better ownership from local communities of their resources. Looking at the role of TESSA in helping ecosystem-based adaptation approaches in Burundi in Africa, looking at options for alternative crops because of issues around water shortages, and also reforestation strategies to allow people to have less dependency on crops that are going to not be very productive in view of climate change. And also in Cameroon, looking at an area where cocoa plantations are being established, where the results were presented to the local community, and they decided, based on the information on water quality and carbon, that they would prefer to explore keeping their natural forest and earning benefits from that in its natural state rather than converting it to cocoa. So just to summarise then at the end so where we're going next with TESSA. So there is a version available online, but it is a working version because we're constantly trying to improve it based on the feedback that we get from users. So some of the things we'll be adding over the next year or so will be new modules on coastal protection, cultural services, and also pollination. And we're also exploring capacity development activities. So in the last year or so, we've done a number of training workshops, both in Africa and also in Asia. And these have been a great success, training a number of people working in international and national NGOs and in the universities to actually go out and use the tool and then come back to us with comments and feedback. So this is the link to access TESSA via the BirdLife website. You need to fill in a short registration form and then we will send over the toolkit. At the moment, as I said, it's a rather chunky PDF document. Don't let that put you off, because actually a lot of the content will not be relevant for your site. So you just need to make sure you read the methods that are appropriate. And to let you know that hopefully by the end of this year we will have a website up with lots more information, example case studies, support, and also a much more easily accessible toolkit that's split into different modules with some parts of it available offline as well. So please do keep checking back as we develop this further. So just leave this slide up perhaps so that you can see the resources that are available. I'd just like to acknowledge everybody who's been involved in developing this, and also thanks to the Cambridge Conservation Initiative for support. Thank you.
Great. Thank you very much, Jenny. I think that was a very useful and clear and insightful presentation. We will now answer a few questions that have come through, and then we will stay online for a little while in case there is any other questions out in the audience, and then we will have a quick wrap-up. So the first question that we have received is possibly been answered at the end of the presentation there, but we had a question saying, is there a manual or book available about the TESSA toolkit?
Yes, so I've just put this slide back up. So this link will send you to the page where you can register to download the manual. Yeah.
Great. And a second part to that question was, is it possible for this presentation to be made available for future use? Certainly a copy of today's webinar will be available on our SGA network website. However, I'm not sure. I'll hand over to Jenny to confirm whether or not she's happy to share the copy of her actual PowerPoint presentation.
Yes, I think that will be fine. Some of the figures in there are actually in papers that are waiting to be reviewed, so I might just have to block out a couple of those for the time being, but it should be fine.
Okay, that's great. And a second question we have received is about the marine ecosystem services. Has TESSA been applied to marine ecosystem services derived from seagrasses?
Okay, so that's a very interesting question, because we've just been discussing recently how to make TESSA more applicable to coastal and marine ecosystems. At the moment, it's only been trialled in one site in Madagascar, which is mangroves rather than seagrasses. And the person that did that looked at a number of services from mangroves, including carbon, harvested wild goods. We haven't yet explored how we might be able to look at seagrasses, but that is a potential development for the coming year.
Okay, great. The questions are coming through thick and fast now. With the next one we have is, how do you merge data from different nature? So qualitative and quantitative data, so for global assessments of different ecosystem services.
Okay, perhaps I'll split that into two parts. So in terms of merging the data that the toolkit will get, some of those graphs I showed you did compile information where it had been gathered in an economic way. But of course you may not be gathering economic information for all of the services. So the slide that I showed, which had the 2 rose plots, I don't seem to be able to move back to it here. Yeah, I'll just whiz back. So this slide here, which shows what are called rose plots, actually puts everything onto a nominal scale with a ratio so that you can compare services which have been measured in different ways. So in this case, water quality and provision were not given economic values, but we were using this approach, we're able to put them all onto the same scale. So that's how we've dealt with the merging issue. And then you mentioned a global assessment. So the toolkit is aimed at looking at site scale work. So I'm not sure how to answer a question about looking at the global scale. Perhaps that's for another presentation.
Okay, great. We have one that is asking, how is the TESSA toolkit related to Invest or any other software?
Okay, so that's a good one. So we do give an overview table in the paper, which I provided the details of at the end, which talks about how TESSA is different from a lot of these other tools out there, including Invest. So that's this Pay et al. Paper under the publications with the DOI link there. Essentially, TESSA doesn't require computer software, so Invest runs through a software system and produces spatial maps. TESSA is more an on-the-ground methodology where you go and talk to local communities and gather data, and it doesn't have its main output as maps. So those, I think, are the core differences. I also think they're complementary. So a lot of the information that Invest requires can be obtained through using TESSA. So for instance, if you want to have tons per hectare values of carbon and you don't want to use lookup tables for that, TESSA would allow you to collect local information to then plug into Invest models. So we're actually exploring at the moment how that complementarity can be realized, and perhaps looking at maybe trialing TESSA and Invest at one site to see how they can perhaps work together in some cases.
Great, that's very interesting. The next question is, does the toolkit provide new methods for accessing any particular ecosystem service, or does it provide a set of references to existing methods for the user?
Okay, so essentially the toolkit draws together standard methods that many people will be familiar with. So that was the reason for involving 50 or so experts on these different services at the beginning. So I would say that the methods are perhaps not new, but more adapted so that they are what we consider to be the simplest way of doing something to get good, reliable data. So it does provide references in some cases to existing methods. So if we talk about doing workshops, we will provide links to resources on how to run workshops, how to ensure you're including the right people, how to do good participatory approaches. So we've tried not to rewrite what's already out there, but to provide links where relevant.
Great, thank you. And I think here we have one that's maybe linked to the last question somewhat. What do you think about the great number of software and tools that have been developed for assessing ecosystem services?
It's a very open question. I think it's good that there are lots of people developing different ways of thinking about ecosystem services. I also think it's good that they focus on different scales. So like I said at the beginning, some of these softwares are very good for looking at big catchments or landscapes, others much better at looking at small sites. I guess there could perhaps be a bit more communication between these different groups of developers in terms of being clear on how they fit together, how they're different, and I guess trying not to confuse users with which might be appropriate where. So perhaps there does need to be a bit more simplification or bringing together of these tools under some sort of umbrella so that people can more easily understand what they're useful for and which ones can be used in which circumstance.
Great. I think that's a nice summary. We have a couple of questions I think Jenny will be able to possibly answer in sequence here. So can you use the TESSA Toolkit for monitoring ecosystem services? And then what is the suggested size of the study area for TESSA?
Okay. I'll do the size one first because that's easier. So I think I showed very briefly on one of the slides that what we've suggested based on our experience to date is anything from, let me check, I think 100 hectares to something like 100,000 hectares. So, you know, obviously the bigger the site, if you're just doing surveys in one area, they won't be representative. So if you have a large site, it's probably good to do a number of sub-surveys so that you get a good spread. So in terms of keeping this a rapid tool, that's why we're kind of suggesting keeping the size of your area fairly small. Most of the sites I've done have been in the tens of thousands of hectares, so maybe 20, 30,000 hectares, where it seems to work well. So looking at monitoring, this was one of the original objectives of developing the toolkit. At the moment, it's very much focused on a one-off assessment, but we're very keen to explore how people can use it for monitoring. Some services are easier than others, of course. So for carbon, some of the one of the methods, for instance, in forests suggests that you tag the trees so that several years later and periodically after that you can go back and then measure the tree growth and look at the carbon sequestration over time. For other services such as harvested wild goods, this would be much more difficult because people might harvest different quantities of goods for different reasons over time. They might switch the goods they're harvesting for various issues, climate change, one of them. Prices will alter related to the economic system. So for services like that, we haven't addressed monitoring yet because of all those complexities. But again, it is something that we're interested to explore.
Thank you. And in your last point, you referred to the rapidity of the tool. So a question related to that is it fair to summarize TESSA as a type of rapid assessment where data is summarized for decision makers but largely not numerically quantified?
Yes, I would partly agree with that. So it is definitely a rapid assessment that you might do at a site where you see an opportunity perhaps for using ecosystem services, maybe as an argument for conservation or just to try and get better information into decision making. If you were then going on to think about something like RED or payment for ecosystem services, you would need to do a more intensive assessment. So in terms of your comment saying, yes, it is rapid, and summarizing first cut information for decision makers, that I would agree with that. With the numerically quantified bit, I would disagree because all of the services are quantified at the moment, and then some of them in economic terms as well. So it does present numerical data.
Great, thank you. We have a couple of sort of technical questions related to the capabilities of the tool. The first one, does TESSA integrate a kind of hydrological modelling to assess water provision and water regulation? And the second one, is TESSA useful for assessing ecosystem services of fragmented landscapes such as high nature value farmlands, and are there any examples of that?
Okay. So looking at the hydrological modelling question, yes, so I mentioned WaterWorld being a tool which we refer to in the toolkit. And I won't go into all the details because I'm not the expert, but Waterworld essentially allows you to run a scenario on a map where you've pinpointed the area that you want to look at. That might be a protected area. And it allows you to see how the water services of that area might be affected if you tweak perhaps the amount of forest cover or the amount of crop cover or the climate. And it does that by having about, well, several hundred baseline hydrological maps in the background which it draws upon to provide that information. So you don't need to add any of your own data other than telling the model what you want to compare in terms of your land cover. There'll be more details on the website which I provided the link for, which will hopefully explain how that tool works in more detail. So looking at fragmented landscapes and farmlands, so I would say it depends what you wanted to look at. If you were looking at whether fragmentation was an issue, you might be able to get some information from using TESSA, but I suspect you would also need to do some other scientific work to understand that. If you were just looking at perhaps what the small fragments were able to provide in terms of services and how that might be different compared to a larger patch, you could potentially use TESSA to say a number of things at the first level. There's no examples that I'm aware of where TESSA has been used at multiple fragments and then pulled together. It has been used to look at farmlands, but not under that context. I'm not sure if that answers your question well enough. But
if there's any follow-up to any of these questions, please do feel free to send us an email or join the webinar forum discussion after this webinar has finished. So I think we have two final questions here. You mentioned in the journal Ecosystem Services that the toolkit could be developed to use for the purpose of monitoring of changes in provision of ecosystem services. Are you going to add some special features to the toolkit?
Yes, quite possibly. So we've got a long list of things that we want to develop, some of which I showed at the end there. It is likely that we will, once we've managed to think a bit more about monitoring and the implications in terms of collecting the data over time, that we will then add some more content to TESSA to guide people in how they might use it for monitoring. Yeah.
Great. And one final question to wrap up this Q&A session. Would Jenny welcome feedback on the ease of use of the suitability of using TESSA in different sites and contexts? If so, is there a form to complete?
Absolutely, I would very much welcome feedback. There isn't a form to complete at the moment, but if you register for the toolkit, there is a box that you can tick to say you would be happy to share the outcome of your study, and that includes any feedback you might have. So when you register for the tool, perhaps just make a note in the text box, and then I look forward to hearing your comments.
Great, thank you very much for those answers and indeed for all of your questions. So I'd just like to say thank you very much for everyone's participation and questions in today's session. I think there was a lot of very insightful questions being asked there at the end, and if you have any more questions at all, please do use one of these SGA Network resources to get in touch with us. We will be available on the SGA Network forum at the top of your screen there for an hour immediately after this, but obviously the beauty of a forum is you can leave questions there and we'll get back to you whenever. So also would like to finish by saying a very big thank you indeed to Jenny for today's presentation on TESSA. Certainly very interesting from my behalf. Please do go to the forum as I've mentioned a couple of times there. And finally also please remember that we'll be holding you a second webinar on natural capital accounting on the 6th of May and we would love to have you join us again for that. So very many thanks on behalf of the SGA Network Secretariat, and goodbye for today.